The closer to the poles it is, the north and south poles, is where it gets less sun radiation. The more toward the equator it is where it gets more radiation. It gets more radiation toward the equator because the sun is pointed directly at the equator. On the table, it has the same numbers on each side, going from closest to the poles to closest to the equator, which is where it gets the most amount of radiation. The HR 8799 emits more energy than the sun because the HR 8799 is one group of stars that the researchers have been tracking. HR 8799 is nearly twice as massive as the sun. It is about 5 times brighter. It is much hotter. Since it is much hotter, it has a light blue color rather than a yellow. Now, as you can see in the graph, how it curves highest in the light blue section, that is the HR 8799. Since the HR 8799 is light blue and the curve is at the highest point there, the HR 8799 is clearly hotter than the part where the sun is in the orange and yellow section. Ultraviolet light is the kind of light that gives you sunburns, and the HR 8799 is in the ultraviolet section on the graph. So in that case, the HR 8799 can give you sunburn. In this unit, for me, the rotating globe on a pipe with a light at the end was most helpful. This model helps show me where the sun points most on certain sections of the earth at different times of the year. As you rotate the pipe where the globe is, the sun points on different sections of the earth, which creates night and day in the different seasons. Today was sure a cold winter day. As Earth orbits the sun, winter occurs when Earth is furthest away from the sun. Winter occurs when the Earth is furthest away from the sun because when the Earth is far away from the sun gives that part of energy less heat, energy, and radiation than it does in the summer. So in the summer, when the Earth is closer to the sun, it gives it more energy, radiation, and heat, so it is hotter. While in the winter, the Earth is further away from the sun, so it is colder.